Hi everyone! Today we're going to be discussing how to rewrite and solve quadratic equations using completing the square. So completing the square is typically used to convert from standard form, which is y equals ax squared plus bx plus c, where a, b, and c are coefficients, to vertex form, which is y equals to a times x minus h all squared plus k, where a is a coefficient and hk represents the vertex. Let's take a look at our first example. Here we have determined the vertex of the quadratic equation x squared plus 6x plus 7 is equal to 0 using completing the square. The first step you want to do to convert from standard form to vertex form is the inverse operation of your constant c from both sides. In this case, our constant is positive 7, so we are going to first subtract 7 from both sides to get x squared plus 6x is equal to negative 7. Next, we're going to determine the b value and compute the value for b divided by 2. In this case, our b value is 6. 6 divided by 2 is equal to 3. Then we're going to find our b divided by 2 squared value and add it to both sides. So in this case, our b divided by 2 value is equal to 3, and 3 squared is equal to 9. So I am then going to add 9 to both sides and then simplify to get x squared plus 6x plus 9 is equal to 2. Next, I'm going to factor the equation to write the left side of the equation in vertex form. X squared plus 6x plus 9 rewrite as a product of binomials x plus 3 times x plus 3, which can be rewritten as x plus 3 squared. And then we're going to solve for the variable. Next, in order to get to vertex form, you want to compute the inverse of the constant and bring it back to the other side so the equation equals to 0. In this case, our right side of our equation is equal to positive 2. So we're going to subtract 2 from both sides to get x plus 3 squared minus 2 is equal to 0. Therefore, the vertex of our quadratic equation will be negative 3, negative 2. Our h value here is going to be positive 3, but we take the inverse since it's inside of the parentheses. And our negative 2, which is our y value, will stay as is. Example 2 now, we are going to look at the exact same equation. However, instead of determining the vertex, we are going to solve the equation to determine the solutions. So same thing as before, we're first going to do the inverse of the constant, determine our b value, which is 6, divide it by 2, which is 3, and square it to get 9, and add it to both sides to get x squared plus 6x plus 9 is equal to 2. Again, rewrite our quadratic as a product of binomials, so in this case, x plus 3 times x plus 3, which can be rewritten as x plus 3 squared. And then we're going to solve for the variable. So in this case, in order to solve, to get rid of a squared exponent, we are going to take the square root of both sides to get x plus 3 is equal to plus or minus the square root of 2. Then we're going to subtract 3 from both sides to get x equals negative 3 plus or minus radical 2. Because this cannot simplify any further, these are the roots of your quadratic equation. If the number was a perfect square under the radical, you would be able to simplify the radical further and then separate into two answers, one being your number plus your perfect square and one being your number minus your perfect square. I hope this clarifies how to use completing the square to solve quadratic equations. Please take a look at my other quadratic videos, including factoring, key features, and quadratic formula. Thank you for watching.